pipe. It's powered by a motor through a gearbox, and so the auger twists around and lifts the earth up through it like an Archimedes screw type design, and then the earth falls out through this T here in some kind of container for carting away. Nanovac, it's powered by a 4 horsepower IC engine which goes through a reduction gearbox. Then we've got the pulley system which drives this piston. The belt on the pulley means that it's quite safe, so if anything jams the pulley will just slip, the belt will just slip. This piston has 2 check valves on it, so this check valve turns into the suck hose and this check valve turns into the blow hose. You can then connect either the blow hose or the suck hose to the valve system, which comes through this hose to the vacuum tank, and then the vacuum produced in this tank sucks up the waste through this waste hose here.
My name is Simon McKean. I work along with Partners in Development and Engineers Without Borders. I'm here in South Africa in the Engineers Without Borders placement, where part of my job is to help develop the pit emptying technologies. These technologies are basically machines that are used to empty pit latrines, perfect for the private sector and for an entrepreneur who wanted to start his own business within his own community. If he feels that there's a market in his community, this machine, we hope, and we've certainly designed it for this purpose, that it's going to be cheap to purchase and cheap to supply parts and cheap to make. So this would be perfect for a single entrepreneur who wants to start up his own business.
Another idea is to develop a chemical or biological agent which could be added to pits to significantly reduce the volume of the contents. Dozens of products are now on the market in South Africa, claiming to aid the management of pit sludge.
One of the problems with establishing whether the additives have value is that there's no South African standard for establishing whether these products work. There's no lab protocol, there's nothing that people can get as a standard approval.
Our current research on pit additives is threefold. There are some laboratory-based tests that are going on where we're looking at the additives in laboratory trials. We're also undertaking full-scale trials where the additives are being added in the field and the height of the contents of the pit are measured periodically, and we're estimating the rate of increase of pit height with time. And finally, we're developing a laser scanner that enables us to very quickly take a picture of the depth of the material in the pits.
In one of our most extensive field trials of an additive, we tested a product which has been commercially, we understand, fairly successful. We tested it out on a site with 40 pit latrines, 10 of which were selected for the additive. 10 we used just coloured water, 10 we used water coloured with molasses, which looked similar, and 10 we just used, we did nothing.
In terms of the reduction of the sludge content in the latrines, actually there was no significant difference between the product that we were testing and our controls. They almost all follow the same pattern.
As a result, we've done quite a lot of work on testing these products. We've tested over 20 products, both in the laboratory and in the field. And to date, we found absolutely no evidence that any of these products make any difference at all. So we've had to conclude that they are in fact a waste of money.
To date, with all the additives that we've tested, we have not found any additive increasing the rate of degradation of the material in pits.
The reality then is that there is no way around the fact that municipalities are soon going to be faced with full pits.
So what happens when the pit is full? Well, you have to empty it. You can suck it out, you can dig it out. We have to find ways that make it safer and more dignified. And it's cheaper to empty a toilet than to rebuild the toilet. It can even be cheaper than to move the toilet. It's astonishing that in this day and age, when our civilization has produced so much advanced technology, think of the computer and communications revolutions, for example, our technology for emptying pits is frankly still in the dark ages. We have to find a way of making pit emptying safer, more convenient and more dignified. I've no doubt that it can be done. It's simply a question of priorities.
What will municipalities do with the sludge that they remove from pits? is it too dense to be treated as septage? It is often full of rubbish which can jam machinery and poses a risk to anyone who comes into contact with it.
Latrine sludges arriving at the wastewater treatment works pose several problems, and in particular impact on the overloading of the plant and process. Firstly, the screenings and grit associated with this type of sludge compound our problems with regards to blockages and wear and tear on plant and machinery. This was evident at our Genazzano works when a trial run was done with the VRP sludge, and there was enormous blockages and wear and tear on the plant and machinery. Secondly, for example, at our Phoenix works, where the daily flow is 20,000 cubic meters a day, we generate 8 tons of dry solids per day. If we were to accept just 20 cubic meters of the VRP sludge, which had a solids loading of between 25 to 50%, although this would constitute only 1% of the inflow volume, it would impact with regards to a 62 to 125% excess load on the plant. This was again proved evident at our Genazzano works, where we had complete process failure and it took a month to get the plant up and running again. Thirdly, even if we were able to get these sludges into the wastewater treatment works, it does not make sense to liquefy it, pass it through a digestion process and try and stabilize it where it is already partially or wholly stabilized. Then further dewater it to a sludge cake of 25%, and then it would be the responsibility of the works to now dispose of this sludge.
Clearly, there are no easy answers for disposing of sludge. But are we perhaps making a mistake to think of it as a waste to be disposed of? Feces and urine are rich in nitrates and phosphates, and before the arrival of waterborne sanitation, these human byproducts were utilized as a resource.
What can you do with the waste? Well, so far the safest and most practical, economical option we've found is to bury it in the ground and to plant a tree or several trees over the site.
At the what we call the Umlazi, the old Umlazi e-ponds, which was ponds that were discontinued approximately 10 to 15 years ago, and about 3 years ago we entered into an agreement with the then Department of Water Affairs to use this as a test site where we could bury sludges underground and we could actually scientifically map the path of the underground water and the pathogens, etc., etc. But that's where we're going, and this is hopefully will be utilized by the Department of Water Affairs.
We're looking at the changes in characteristics of the sludge, but what I'm actually looking at here is we're looking at the migration of pollutant from the various sludge down to these boreholes here. Up till date, I think the barrier started sometimes in 2008, and I've been monitoring water from this borehole. I think I've got a year data sampling, and up to now we haven't seen any changes as regard the characteristics of this groundwater, meaning that up to now what is happening at the barrier site, we haven't seen anything affecting the groundwater.
Okay, right here we are taking some sludge samples for testing in the laboratory for the microbes. We want to check how it degrades over time after it's been buried in the trench here. Ngapha kwa right farming izihlahla ezatshalwa ngaphambili kwalezi zihlahla lezi ezitshalwe kule row le. So lana kule row sinendle lapha isilage sifakiweyo and siseduze kakhulu nesurface. So kusho ukuthi lana le izihlahla lezi seyikhulile zafika kwisilage la impande zakhona, so kukhona umthetho ezothola nje ubona seyikhule kakhulu nje zidlula lezi ngapha. Lezi zatshala kade kakhulu kanje 3 months difference ispace sokutshala, so ukhomba ukuthi indle khona into yenzayo enomsoco ewupha izihlahla.
The WRC research team is also exploring the option of households using sludge on their own properties in the same way. Sludge is buried underground and a tree is planted above it.
No, Mrs. Cole. I don't know what's going on. isihlahla ngabona ukuthi sikhula kahle asikhuli njengalezi ezinye zakhula kahle nje sikhula masinyane zathela futhi amapilisi sawadla mnandi nomakhelwane-ke njini bakuthanda le bathanda ihlahla bathanda ukutshala lezi ihlahla ngalo mquba wenhle bahawuka-ke osho ukuthi-ke bathanda bona bayothanda nabo ukuthi botshalela umakhelwane.
While research is still in progress to understand how to safely use sludge in agriculture, these studies demonstrate that there is enormous potential for disposing of sludge in ways that recover its nutrient value, contribute to food security, and reduce the need for dedicated disposal sites.
You know, from the WRT's perspective in dealing and foreseeing these challenges, we have a multi-pronged approach in terms of our research support in finding solutions. Now, we are busy with these research projects and we have made significant improvements or built the necessary knowledge base in terms of the science, and I think we're moving towards now providing solutions.
Providing decent sanitation to all South Africans is clearly not simply a matter of building enough toilets, but the complex challenges involved in making sanitation work also raise exciting possibilities for smarter management of our resources.